operations with functions. We can add, subtract, multiply, and divide functions, and we can bury them or embed them in each other, and that's called composition of functions. So on this first one, we're going to combine these two by adding. When it says f plus g of x, it means you add your two functions before you put in your numbers. So that's all there is to it. When you combine like terms, you get x squared plus 4x minus 1. So we've combined those two functions. Now we're going to subtract f minus g of x. That just means we subtract the functions. We have to distribute our negative, and then we turn it into an adding problem, and we get x squared minus 2x plus 1. On this third example, we're multiplying our functions. So if it says f times g of x, that's the same as f of x plus g of x. So here we're going to multiply the functions. We can use the box method, or we can distribute x squared times 3x is 3x squared. Then we combine our like terms, and that's all there is to that. And then when we divide functions, that's a funny looking notation, but f over g just means we write the two functions one on top of the other. We can use synthetic division or polynomial division if it asks for it, but most of the time we're done. And that's all there is. There's one more kind of operation called composition of function, and that is where you put one function and take the answer and put it in another function. So it looks like you're saying FOG function, F-O-G or G-O-F. This is not the same as timesing. It's an open circle, and it just means we're putting one in that circle. And another way to write it is you can say g of f of x, and in that case, f of x is going inside of g of x. This is how it looks. All right, we're looking for f of g of 3. So there's several ways to do this. Right now, I'm going to find g of 3. Then I'm going to take that answer and I'm going to put it in f. So g of 3 is 3 plus 1, which is 4. I'm going to take 4 and put it in the other function. I'm going to find f of 4. And so that's negative 2 times 4, which is negative 8. And since it's an absolute value, it's the absolute value of negative 8. So that's 8. So you can say f of g of 3 is 8. You could also write it a different way. You could write f of g of 3 as an additional way to write it. All right, let's try another one. We're going to do g of f of negative 5. This time we're going to write f first. F of negative 5, and then we're going to put that answer into g. And g of x equals whatever we get plus 1. So f of 5 is negative 2 times 5. And it's negative 5 here, so that's going to be an absolute value on the outside. So that's the absolute value of 10, which is just 10. We're taking that number, we're putting it in the next function. We'll have 10 plus 1, and that's 11. So you could say if f of x is a bunny suit and g of x is the super suit, f of g of x, you take the second one they say and you put it in the first one that they say. So it is f of g of x, you take g of x and you put it in the bunny suit. Right on the next one, g of f of x, we're taking the result of f of x and we're putting it in the g of x. So let's try another one. We've got two functions here. We're finding f of g of 9. So we're going to start with g of 9. So that's going to be the function g of 9. And that's going to be the square root of 9 minus 4, which is the square root of 5. Now we're going to put the square root of 5 into f of x. So it's going to be f of the square root of 5. And that is the square root of 5 squared plus 5 times the square root of 5. So we can square the square root of 5 and we just get 5 plus 5 square root of 5. And that is our answer for f of g of 9. You could look at it this way. All right, if you have f of g of x, and g of x is the pineapple, we're putting the pineapple into the function f of x. So the pineapple is going into the pizza. Now, if you have g of x and you're plugging in f of x, you're plugging the pizza into the pineapple. So on this next one, we're going to plug the whole entire function in because it doesn't tell us a number. So it looks complicated, but I think it's actually easier. So if they say we want f of g of x, that means g of x is going into f of x. So here I've written f of x, but every time I'd have an x, I'm going to put in g of x. So I'm going to write it down here by hand. So I'm going to put in g of x, which is x squared minus 4. That's going in where x would. And then we've got plus 7. So we can simplify this. The negative 4 and the 7 are like terms, and so that's how we get x squared plus 3. That's our simplified function once we've embedded g of x into f of x. All right, now, if we're going to have g of f of x, I'm going to pause here and then we'll pick up in just a second on the next video.